All right, guys, today we're going to be talking about inverses of functions 2b.2. I can find the inverse of a relation or a function. Actually, we've taught inverses quite a bit, and really you didn't realize that that's what you're doing. But let's take, for example, again, just trying to use common examples to help us kind of know that we've kind of already talked about some of this stuff. But if I had 2x plus 4 equals 8, right, how would I go about solving for x? Again, I'm always trying to figure out what the value of the variable is. And so in order to do that, I need to isolate that variable and get it by itself. Well, in order to do that, we do what's called inverse operations, right? We have to, in other words, we have to get this positive 4 over to the other side. Well, in order to do that, I have to do the inverse of adding 4, which is what this symbol is telling me it's doing now, and I have to subtract 4, okay? And so I would kind of work out this problem a little bit more. 2x equals 4. And then again, in order to get x by itself, I need to do inverse operations. So the inverse of multiplying something. Remember, there's multiplication implied between a number and a variable. So in order to do this, I've got to do inverse operations. Again, I've got to divide by 2. So x equals 2. So I want you to see here that this is something that, again, that we've seen a lot of times before. We've talked about inverse operations, but now we're talking about inverses of functions. So what I want you to think about is when you're talking about inverses of functions, if two functions are inverses, they consist of inverse operations performed in the opposite order. Now that sounds really, really complicated. But we're actually going to make this really, really easy. Before I do that, I want to show you some pictures here of some work that I got from some students a couple of years ago. We did a coordinate grid activity, and 2 students turned in their work. And I want you to just look at this work and see what you think may have happened. So let's look at this real quick. This first one here, this was, again, a graphing activity where they had to do some math, and then they would go ahead and actually sketch out, take each coordinate point, and go ahead and sketch that in. So it kind of looks like an eagle or some type of bird, right? And you notice graph paper A, and it is vertical up and down, looks great, okay? This is one of the papers that I received from a student, but here is the other one that I received from a student. Now I want you to think for just a minute, and I was a little bit taken aback when I got this from the student. I was like, what in the world happened? Because, I mean, most of the papers look like this. So I thought, well, okay, that's probably the way it should look. But I want you to notice, I mean, this bird is actually identical to the way this one is. There's really no difference, but yet it looks like he's turned 90 degrees, and maybe even his beak is pointing a different direction as well. It's like, what in the world happened here? So just think for just a second what may have happened. And then we're going to actually look at some stuff, and then I'm going to show you how and why this happened. All right, so let's go back, a little bit of a mystery. So when we're talking about inverses, let's take a function, for example. Let's say that we have f of x equals x plus 1, okay? So again, we could rewrite this as y equals x plus 1. And again, we said by definition that when you're talking about inverses of functions, they consist of inverse operations performed in the opposite order. So I'm gonna actually go back to those pictures, and I want you just to think about this for just a second. Remember, it said that when you do inverse functions, they're performed in the opposite order, okay? I want you to think about what may have happened here. What may have actually happened, ladies and gentlemen, is that they got their coordinates mixed up. In other words, you typically have x comma y, right? Well, this student down here actually did his y coordinate first and then his x coordinate. And in other words, he switched the 2 coordinates around. And so when you switch the 2 coordinates around, all of a sudden you get the same exact image, but the difference is it's almost like a mirror image. It's an inverse image, okay? So here's really simple how that you find the inverse. In other words, I'm given this function here, and I'm asked to find its inverse. Well, to find its inverse, all I need to do is I just need to switch out my x and y coordinates, just like those 2 guys did on those that particular little activity I had them do, one of them switched his terms around, and that's what made it look the way it did. So in other words, it's going to be x equals y plus 1. Now, the only difference is now I need to solve for y again, okay? So again, I have inversed my x and y coordinates, but now I need to go ahead and solve for y. So in order to do that, I need to do inverse operations, which means I need to subtract 1 from both sides. So I end up with x minus 1 equals y, or I could rewrite it as y equals x minus 1. So again, the way we started this was we first of all converted f of x into y. When we get done, we need to go ahead and convert it back. But remember, it is not f of x anymore. Now it is f inverse of x. Well, how do we write inverse? Well, if you remember back from finding inverses of matrices, we wrote those as like matrix A, for example. The inverse would be a to the negative 1. Well, it makes sense then that when you notate an inverse, you just put a negative 1 with it, okay? So this will become f of negative 1 of x, which means it's the inverse is actually x minus 1. Okay, so this would be our final answer if we were looking for the inverse of this particular function right here. Okay. And again, I want you to look at this graphically, because I think a lot of times if we look at something graphically, then it makes a little more sense. So I'm gonna actually got these two functions already graphed in Desmos so that we can see them. So again, this is my original function. This is the inverse function. And look at what these look like in Desmos. Again, y equals x plus 1 is this line. Y equals x minus 1 is this line. And here's the really interesting thing about this, okay? Notice if I come up here and I just look for some points, okay? Notice this point right here. On this line is 1, 2. All right, my x coordinate is 1, my y coordinate is 2. I can go down here to this one and notice right here that I have an x coordinate of 2 and a y coordinate of 1. So the reason these are inverses is for every point along this line that I have here, I have exactly the opposite point over here on this line. What makes this even more crazy is if I put y equals x, for example, here is this line through the middle. So if I were to take this red line and rotate it over this y equals x axis, it would land exactly on this blue line, okay? So again, kind of some freaky stuff, but you can kind of see how they're getting these inverses, right? Is you're taking the coordinate from 1, here is 2, 3, for example, and if I go over here, I could find 3, 2, okay? So all you're doing is really just switching these around. So let's go through one more example real quick, just so that you'll be completely ready for your practice. So what if I had, for example, f of x equals 2x squared, and I am asked to find the inverse function, okay? If I'm asked to find the inverse, the first thing I'm going to do is go ahead and change this to y equals 2x squared, and then all I'm going to do is the old switcheroo. I'm going to take this y and put it where the x is, and I'm going to take the x and put it where the y is. So I'm going to end up with x equals 2y squared. Now I need to solve for this y, okay? I need to isolate this y. Well, the first thing I need to do, I've got multiplication between 2 and y squared, okay? So let's go ahead and divide by 2 right off the bat on both sides. So that's x divided by 2. All right, and that equals y squared. And then if I need to get rid of this squared term, I need to do the square root, right? The inverse of squaring something is to take the square root. So you notice what we get is the square root of x divided by 2 equals y. We could switch that around the other way. It's really the same difference. But now I need to, remember, I need to restate this as f inverse of x equals the square root of x over 2, okay? So again, all we're doing is we're taking this first equation, we're using y because y and f of x is exactly the same thing. Then we switch out our x and y, and then we go ahead and solve for y, and we will get our answer. So this would be our answer for the inverse of this particular problem right here. All right. If you need any help, make sure that you reach out to us, and we'd be glad to try to help you with this.